Today we are going to discuss an interesting model that simulates the evolution of virtual organisms across generations, responding to various environmental pressures. To start, could you please introduce yourself and tell us a bit about your background?
I'm Christy Kraus, and I guess my background now is in agent-based modeling and modeling of various biological systems. I also have, I have a general background in primatology and behavioral ecology and things like that. So, and then I brought that into the models that I create.
Thank you. So let's start with the basics of your model. Can you explain the purpose of this model and what initially prompted its development?
So generally, it's supposed to be kind of a generalized model of primate behavior and behavior more generally, and ecology. And so I was really interested in developing the model in making sure I included a number of components thought important in modeling socioecology and the evolution of societies. I suppose one of the main driving questions I had was in the evolution of group living, and under what conditions group living evolved. So I would say that was the driving force in it. And additionally, I would say another driving force was simply, I felt that in the models, especially in the primate world that had been developed thus far, we're really only tackling specific species or specific kind of topics in socioecology. And I thought it was important to try and bring a lot of that together into one coherent model. Just because I see, it might be the case that people are reinventing the wheel or, not considering components that might also be important. And so kind of having them holistically in one model seems important if you're going to test hypotheses in behavior and ecology.
What were the main challenges you encountered while developing this model, and how did you address these challenges?
Lots of challenges. I think if you ask any person who's made a model, it's just very difficult to develop. Some of the challenges that I remember having is just putting all of the components together. I wanted the agents to forage, and so they were foraging for energy, and then they needed to use that energy for things like reproduction and growth, and then kind of getting it to the next generation. So, okay, I needed the agents to be able to do that well enough to reproduce the next generation, and that next generation then needs to develop enough to start foraging so that it can kind of continue on indefinitely. And just getting that kind of the initial process going was very challenging, and it really came down to just tweaking certain parameters until they were able to take off.
Mhm. Okay, so moving on to the insights from the model, what are the main outcomes or, findings coming out of your model analysis? And can you share an example of how such findings can be applied or, have influenced real world understanding or applications?
I would say general insight that I have found in various simulations is that the agents in a lot of cases will find a way to reproduce and persist, but it's not necessarily the case that they will arrive at strategies that I anticipated they would have. So I think in general, it's just a good reminder that, well, for one, it really highlights the benefit of using a model where every component is kind of recorded and understood, so you can really understand where those strategies emerge from. And then also kind of bringing it into the real world, we may not fully understand why certain strategies are emerging and that we observe, and that we may not fully appreciate all of the components involved.
You have made your model available on comsys.net. What steps did you take to ensure that your model is, understandable and usable by other researchers? And what challenges did you face in this process?
I would say that while my model B3GET has a lot of simple components to it, from the user perspective, I think because of that, in part because of that simplicity, there are a lot of options available for what the user can do. So kind of trying to explain just generally all of the options available, and then trying to tailor that to a particular research question can be challenging. I created a user manual to kind of guide the general user through how to use B3GET, but there's a lot going on, and it's not necessarily intuitive, how to set things up. I think in the future I'll like have a series of YouTube videos or something to help people. But yeah, just kind of like communicating exactly how to use the model has been challenging.
Mm-hmm. So, did you have any challenges in the process of archiving your model using the comsys.net platform?
No, it was very straightforward. So thank you.
Thank you. So, uh, looking towards the future, what's next with this topic? Are there, follow-up studies already available or planned, and what directions, do you see this research heading?
Yeah, one thing that I've talked a lot about with my PhD advisors, in particular, is like incorporating neural networks or some ability to capture, to create brains that these agents have beyond what they have right now. So something a little more complex, so that we can really understand how cognition plays into kind of all of these other components. And then from there, take it to more complex directions, like more complex forms of communication, maybe language, things like that. So I think that's definitely an intriguing direction to go. Some more boring directions would be just adding more features to the landscape, water resources and things like that, and just additional details that will make the whole ecology more rich.
Mm-hmm. That's interesting. So, thank you for sharing these insights with us today.
Yeah, thanks for having me.